So this evening we're going to talk about, or I guess during class today, we're going to talk about interpreting graphs. So yesterday you watched a video about how you go about making a graph and then looking at good graphs and bad graphs. So today what we're going to do is we're going to look at how do we then read the graph or interpret the graphs we know. And this is a really important skill because as you move through school, it is a lot of what is on tests and things, or understanding the world around you is really important for understanding how graphs are presented. So when we look at graphs, it's important to be able to read and analyze and interpret them. So especially like in the right now, you might look at a graph about COVID, or you might look at a graph about car ownership or something like that in the newspaper or online. A lot of times data is presented in graphs. So we want to make sure that we know how to do that. So graphs are used to show patterns and trends and relationships, and sometimes it's easier to look at information in a graph than it is to look at it in a data table because we can visualize or see exactly what that data is about. So we've kind of come up with 3 steps, 3 ways to help you understand graphs. So the first thing you want to do when you look at a graph is to look at the title. And this should tell us a lot about what the graph is about. Sometimes the title is misleading though, or the graph doesn't give us all of the information. So step 2 is to look at the x and the y-axis. If you look at the x and the y-axis, the x-axis is the one that goes this way and the y-axis goes this way. So x is here, y is here, and the independent variable is almost always on the x-axis or on the bottom. And then the dependent variable, what you're measuring, so you can see the differences in what you're measuring, right? Makes it more sense, is on the y-axis. So x, independent variable, y, dependent variable. So we want to look at that because that often gives us a lot of information about what's being included in the graph. And then lastly, we want to look at the data that's on the graph. What do you notice? What patterns do you see? Do you see areas where the data is higher or lower? Do you see things where there's trends? That's where the data tends to move in one direction or another. So maybe the trend is that it's increasing or decreasing, or it's staying the same. So we also want to look at the x and the y-axis for another reason. So I'm going to go back up to number 2. One of the things that people do sometimes is they manipulate or change the y-axis, the way the measurement is, to make the data look different. So if you remember the one yesterday about football wins for Arkansas, I think. If you looked at that one, when they made the data first, they set it up so it looked like there was very little difference between the wins from one year to the next. But if you really looked at the data when you actually spread it out, the difference was bigger. There was a bigger difference in the data than was initially determined. So we're going to watch a little bit. So let's practice with a little bit. We're going to practice graphing with just looking at this. It's just kind of silly. So we'll see what happens here. So it says, what do we notice? And what we notice is that dogs are definitely, I'm going to unmute that, or mute it. They are definitely obsessed with laser pointers. So we saw a red one and a pink one, it looks like. An orange one maybe. I don't know what color that is. I've never done this to my dogs. Maybe I need to play with my dogs with a laser pointer and see what happens. They look a little crazed. Oh my, look at that poor dog. Okay, so we're not going to watch 3 minutes of this, but if you want to go back and watch the dogs chase laser pointers, you go right ahead. But that might lead us, sometimes seeing things like that leads us to a question. So maybe that led somebody to the question, a question about this topic. So maybe they came up with a question and did some research. So maybe they asked, does the color of the laser affect how fast my dog runs? Maybe. So we can look at this data table and figure out some of the information that they learned from it. So let's examine this this graph. So first we want to look at the title. So what does the title tell us? And then we want to look at the x and the y-axis. So let's go ahead, and then we're going to look at some observations about the data. So first of all, this graph tells us how different colored lasers affect how fast dogs run. We can get that by looking at the title. Okay, so what we're going to find out here is if different colored lasers make dogs run faster. Then we're going to look at the x and y-axis to see if they make sense. Okay, so let's see, they tested different colors. So we can see, okay, they tested purple lasers and pink lasers and blue lasers and green lasers. So what we can only make conclusions about or get information about are those 4 colors. So they had 4 different alternative hypotheses. And so they were talking about the different colors of lasers. So we can't make any conclusions about, let's say, yellow lasers or maybe, what other color? I can't even think of another color right now because I'm not thinking. And then we look at the side here. We want to look at the scale and see, does the scale make sense? And then they're talking about the average speed of dogs. And interesting, they did it in miles per hour. Since we're in science, I would have liked to have seen kilometers per hour, but miles per hour makes more sense to us. So we looked at those 2 things and we kind of get an idea. And now the next thing we want to do is make some observations about the data on the graph. So I could look at that and I can say, well, I can observe that the green laser is the highest by a lot. So that seemed to make the dogs run the fastest. I observed that they responded to purple and pink about the same, so that was about 10 miles per hour that they ran, and that the blue laser is the lowest. So we could conclude in this graph that green lasers cause dogs to run faster than other colors. Okay, than the other colors in this test. We can't say that all other laser colors, we can just say than the other colors in this test. So let's look at another graph and see what we can figure out. So this graph, just take a brief second to look at it and think, what do I think I'm going to learn by looking at this graph? Okay, so step 1, let's read the title. The title says, does the time spent in quarantine affect the number of pets people own in Anoka County? Well, this is interesting. I didn't change my number of pets, but I sure was glad I had pets during the quarantine time. Okay, so then we're going to look at the x-axis, and the x-axis is looking at months. So that's why it's a line graph, because we're looking over time. So we're seeing if there's a change in the number of pets that are owned over time. And then they measure, and then on the other axis, they measured the number of pets owned in 2020. And we can look and see that, we know that quarantine started in March, okay, or end of February and beginning of March, people were starting to stay home. So we want to look at the data and think, okay, what can we learn from this? So what we can learn from this is I observed that in general, the number of pets has increased. So we can see a general trend toward more pets. We can see that the highest number of pets was in October and November, and that the lowest was at the beginning of 2020 before the quarantine even began. And then there was a drop in August, and that might be, we can make some assumptions based on what we know, but all we can really say is that that dropped in August. Okay? So what does this data mean? So you can also use a graph to find specific data points, and this is really a good skill to have. So you can look at we're going to look at how to do that. So one thing that you can do, what you do is, let's say you wanted to know the number of pets that were owned in July. So first we're going to find on the x-axis the month of July. So you can see right here, okay, the month of July. And then what we're going to do then is we're going to follow that up. And I'm going to go over here and click on this one. Then we're going to follow that up to here. And let's say we wanted to know the number of pets. So we're going to follow it up until we find the data point. And then once we find the data point, we're going to follow that data point all the way over here until we can say that, okay, in July, there were 4 pets owned, and that's what it says underneath my face there, I guess. So there were 4. Okay. So let's look at another graph and see what we can find out. So I'm going to ask you to do some analyzing. So step 1, we're going to start by looking at the title. So it says rotifers and zebra mussels in the Hudson River. Wow, that does not tell us a lot about it. So we need to then look at the x and the y axis, and the x-axis right down here. So the x-axis tells us the year. So we're comparing zebra mussels in the Hudson River by year. And what are we looking at? Oh, our y-axis is that we're measuring their density per meter squared. So we're looking at how many there are per meter squared. Okay. Now this is an interesting graph because it has 2 lines on it. So then we need to think, well, what do those lines mean? So we look over here and we can see what the lines mean. So they're looking at the relationship between those two organisms. So if you look here, I'll move it up. You can see zebra mussels here and rotifers here, and we're looking at their basically their density, or how many there are in certain years. Okay, so what I want you to do is think about, okay, what can we learn? Because the title wasn't helpful, so we went to the X and the Y axis. So then if, according to our data here, to what we've learned, we'll go back up here. And the next thing we want to do is we want to, after we look at the X and the Y axis, then we want to make observations about the data. So what do we notice? Okay, so I'm going all the way back down here. What do we notice about the data? So I'm going to ask a couple questions in the video, and you're going to answer them based on this table, on this graph. All right, so let's look at one more graph. So let's look at that one. We analyzed this when we talked about the title. We looked at the X and the Y axis. So now what we can look at is we can say, okay, what's happening? Well, it looks like the populations are related, or the densities are related, because when one goes up, the other goes up, but then when that one gets high, the other one drops. So they seem to be in a relationship with each other. So that's interesting to see that we can guess that. And we can say that the population of zebra mussels was the highest, and we can say what year it was, we can say what year it was the lowest, so we can make some observations about that data. Okay. Again, so we did all of those things. We looked at patterns, we looked at areas that are higher or lower than others, and what we noticed. Okay. Let's look at another graph, one more here. So again, let's have you start with the title. And I'm going to ask you to just look at the graph again and use this title. What do we know, and what about the X and the Y axis? So we're looking at, again, the year, and then the population of monarchs. We're looking at it between 1997 and 1999, or 1997, excuse me, and 2019. So this is a very current graph. Okay. Then we want to think, okay, what can we learn from this graph? So I'm going to ask you a couple of questions about the graph, and then you will be done for today. So when you are done, have a great weekend. I hope you enjoy and get out and do some things this weekend. And I will see you on Tuesday. You'll have an activity to do on Monday, and then I'll see you on Tuesday. Bye, guys.